Alright, this is video 3 for Unit 5, Big Ideas. This question, the first question up here, is actually a Unit 4 review question. So, a square pyramid is packaged inside a box. The space inside the box around the pyramid is filled with protective foam. About how many cubic inches of foam is needed to fill the space around the pyramid? So what we're trying to find is the volume of the space around the pyramid. So this is a composite volume problem because it involves volume of two different shapes, right? So we have shape 1, which is the cube, and shape 2, which is the pyramid. Now if I'm trying to find the space around the pyramid, I'm going to take the volume of the cube and subtract the volume of the pyramid. That'll give me what's left over. Alright, so for a cube, we don't have that formula on our formula sheet, but it's pretty straightforward. It's just base times length times height. So it's a cube, right? All sides are the same. So 5 times 5 times 5, which is the same thing as 5 cubed, which is where the cube comes in. Alright, so on your Desmos app, you can do 5 times 5 times 5, or you can do 5 to the third power, and it will give you the same thing. So 125. So we're going to do 125 minus the volume of the square pyramid. Now remember, the volume of the pyramid can be found on your formula sheet, which is uploaded to Schoology. It's 1/3 base times height. Let me pull that up, and you can just go to Google and go to geometry formula sheet. So the pyramid volume is equal to 1/3 base times height. So let me make sure and write capital B. We know what capital B means. It's the area of the base, right? Alright. So I made that into a capital B. Alright, so our volume of the pyramid is going to be 1/3 is equal, oh my gosh, I'm losing my mind. Volume is equal to 1/3, and then my base, my area of the base is going to be 5 times 5. That'll give me the area of the square base. Times the height of 5. So our volume is going to be 1/3 times 25 times 5. And again, we're just going to plug this straight into Desmos. And on Desmos, we end up getting 41.67. So we're not quite done yet, right? We have the volume of the cube and the volume of the pyramid. We just need to subtract them to figure out the space in between. So 125 minus 41.67. 125 minus 41.67 is going to give me 83.33 inches cubed. Remember, it's cubed because it's three-dimensional, or volume. Alright, so looking at my answer choices, my only possible answer choice is C. Alright, great work on that Unit 4 review. Alright, now back to Unit 5. Okay, so for this question, it says write an equation for a circle with a center at -2, 3, and a radius of 3. Alright, we can write that equation, right? We know standard form. X plus 2 squared plus y minus 3 squared is equal to 3 squared. We plug in our center and we change the signs, and then we square the radius on the other side of the equal sign. So it's going to give me x plus 2 squared plus y minus 3 squared is equal to 9. Alright, my problem is, looking at these answer choices, they're all in general form. But it's okay, we know how to get this into general form. So what we're going to do is expand this by multiplying this binomial times itself, right? Now, if you need a refresher, I can do box method off to the side. But remember in class we got to the point where we were just doing it in our heads. Alright, so it's a binomial squared, so it's something times itself. So I'll put x and 2 up here, x and 2 down here. In the box is x squared, x times x. And this box is 2x. This box is 2x. And this is 4. I have two like terms I can combine. So my final trinomial is going to be x squared plus 4x plus 4. So if we just looked at the binomial, we could figure that out, right? X squared plus 2 is 4. And 2 times 2 is 4. So let's go ahead and try the next one, doing it in our head. So our first term is going to be y squared, right? Because y times y. Our second term is going to be a -3 plus a -3, which is going to give me a -6y. And our last term we're multiplying. So -3 times -3 gives me +9 is equal to 9, because that's what we have on the other side of the equation. All right, let's go ahead and combine any like terms and rearrange the terms to get it into general form. So I have 4 and 9. They're like terms because they're both constants. Let's rearrange. I know I have x squared followed by y squared. So I got that one, I got that one. Plus 4x, which is this one, minus 6y, which is that one. I'll combine my two like terms, which will give me plus 13 is equal to 9. We're almost done. The last step is to set it equal to 0. And to move this 9 to the other side of the equal sign, I'm going to subtract it. I'm going to subtract the 9 on this side, because what we do on one side we have to do on the other. And I lined it up underneath the 13 because that's its like term, right? They're both constants. I can't subtract it from any of these other terms. All right, so my final equation, I'll put it over here, it's going to be x squared plus y squared plus 4x minus 6y plus 4 equals 0. Which would be answer choice C. All right, great work. Okay, for the next one, I want you to attempt it on your own before we do it together. So looking at this, we have to find the center. So what we're doing is going from standard form, from general form to standard form. So look back at the notes we took on the first page with this example right here, where we went from general to standard. This is exactly what we're doing. So follow these steps and see if you can do it on your own before we do it together. So come back when you're ready. Okay, let's review this question, even though I don't even have to, because I'm sure you all did it perfectly. But just in case, what's the center of the circle given by this equation, which is in general form? So what I need to do, step number 1 from our notes, is to move the constant to the other side. All right, my constant is -11, so to move it to the other side of the equal sign, I'm going to add 11 to both sides. So x squared plus y squared minus 10x now equals 11. All right, you'll notice something different about this equation. We don't have a y term. We have x squared, y squared, and a -10x, but we don't have a y term. That's ultimately good for us. That means less work for us. So let's move the x's together. X squared minus 10x plus y squared is equal to 11. All right, so I only need to complete the square for the x group because there is no middle term for the y group. So x squared minus 10x plus blank plus y squared equals 11 plus blank. All right, so what we need to do is fill in this blank. If you look back at your notes from the first page, it tells us to take the middle term, divide it by 2, and square it. So a -10 divided by 2 is 5. 5 squared is 25. What I do on one side, I do on the other. All right, now we're ready to factor this trinomial, this x group. It's going to become x minus 5 squared. Where did the minus 5 come from? It's our middle term divided by 2. So ultimately, this trinomial and this binomial squared are the same exact thing. This is just the factored form. So if I went and multiplied it out like this up here, I would end up with this trinomial. Let's just bring down our y squared because I have no y group to complete the square, is equal to, now 11 plus 25 gives me 36. All right, now I have it in standard form, and I can look and figure out the center. So remember, I switched the signs, so this -5 is going to become positive. So I can ultimately eliminate A, B, C, and D because I know the x term, right? Now, why is our y term 0? Because there's nothing next to the y. I don't have a plus or minus any number. So that means my y value is 0. So A is my answer. If they happen to ask us what the radius is, we know it's the square root of 36, which would be 6. All right, go ahead and pause the video. Think about the next problem. Circle your best answer choice, and we'll come back and discuss. Okay, what information is needed to show that a parallelogram is a rectangle? All right, so when you think parallelogram, I want you to think of our 5 parallelogram properties that are true for every single parallelogram. Number 1, opposite sides are parallel, and I'll use the parallel symbol. Number 2, opposite sides are congruent, and I'm going to use the congruent symbol. Number 3, opposite angles are congruent. Number 4, same side angles sum to 180. And number 5, the important one for this problem, diagonals bisect each other. All right, so that's true for every single parallelogram, no matter if the parallelogram is a rectangle, a square, a general parallelogram. Every single parallelogram, diagonals always bisect each other. So A won't be my answer because that doesn't tell me specifically that a parallelogram is a rectangle, right? Because this is true for every single parallelogram. All right, now looking at these two, we can eliminate D as well because this doesn't help us at all with distinguishing if it's a rectangle. So we're between B and C. The diagonals are congruent and they're perpendicular or just congruent. All right, so we have to remember our special parallelogram properties, and that is for a rectangle, which we reviewed this on the prove side, diagonals are congruent. All right, for a rhombus, diagonals are perpendicular. I'm going to use that little symbol. And for a square, both the diagonals are congruent and perpendicular. So looking at this, B is what describes your rectangle. So what would C be describing? If they're congruent and perpendicular, C would prove something is a square. So we'll eliminate that. All right, great work. Go ahead and start on this next one. I'm not going to give you any hints for it. Just look at the problem, see if you can figure it out on your own, and come back when you're ready. So for this problem, we're trying to find out if this point is on the, if these points are on the circle with a center and a radius. So your center is 3, -9, and your radius is 5. So what you can use for this formula, or for this problem, is the distance formula. This right here is going to be my x1 and my y1. And these will be my second points to plug into the distance formula. I'll know if the point is on the circle if I get a distance of 5, because that's the radius. Remember, the definition of a circle is that all points are equal distance away from the center. So let's go ahead and try the first one. If that's my x1 and my y1, this will be my x2 and my y2. All right. So what I'm going to do is set up the distance formula for every single option, and then we'll just plug them in. So D is equal to x2 minus x1 squared plus y2 minus y1 squared. Notice the minus is part of the formula, and I have a negative, right? All right, I'm going to go ahead and pause the video so I can write all these out. I put all these into Desmos, and I got the following answers. So looking at these, we can see that answer choice D is the only one that has the same radius. So D is the correct answer. And you can see how I put them in.